So the question says each of the four forces acting at E has a magnitude of 28 kilonewtons. Express each force as a Cartesian vector and determine the resultant force. So we've got four forces connected to the four corners of the box, as we can see from the diagram, and this should be tension cables, and we have four forces that are as a result of the weight of the car in the box. So we want to determine express these forces in Cartesian vector form. So to begin with, we're going to make use of position vectors of the line of action of these forces. So first, let's begin by giving these 4 points coordinates based on the x and y axis that we've been given in the diagram. So let's give coordinates to A. We notice that A, the x direction, you're going to move 6 units, so in the positive direction, so 6, in the y direction you're going to move 4 units, in the negative y direction, so negative 4, and 0 in the z direction. Similarly, B, you have 6, 4, 0. For C, we have negative 6, 4, 0. And D, we have negative 6, negative 4, 0. And E, we're going to have 0, 0, 12. Okay, those are coordinates. So let's look at let's try to express the force FEA into Cartesian vector form. What we're going to need is the unit vector of the position vector along the line AE. And how do we do that? Well, AE let's call this EA, because we're moving from point E to A. That's the direction of the force. So EA, want to write EA in the form xi plus yi plus zk, and then we want to find the unit vector of this vector EA. So the unit vector EA will be given by xi plus yi plus zk over the magnitude of this very vector xi squared plus yi squared plus zk squared, which is simply this is simply the length of this line AE. So in some cases you might be given the length of AE to simply be stated, say AE is equal to a particular value, so that is the same as the magnitude of the position vector of AE. So it's to the length EA. So once we have our unit vector U, EA will also be in the form xi plus yi plus z. Okay, so expressing our force F EA in Cartesian vector form would be the magnitude of F EA which we've been given as 28 kilonewtons, and this we're going to multiply by the unit vector UEA, and that's how we express a force, a given force in Cartesian vector form. While making use of the unit vector of its position vector. So let's get into it. Let's determine the Cartesian, let's express EA in a Cartesian vector form. Allow me to divide this page. Okay, so EA will be equal to OA minus OE OA would simply be the coordinates at A. So we've got 6, negative 4, 0 minus the coordinates at E, 0, 0, 12, and this would give you 6, negative 4, 12. So if you write EA Cartesian vector, to be 6i minus 4j plus, sorry, this is also negative, minus 12k, and the magnitude of EA will be equal to 14, which will be the square root of 6 squared, 4 squared, negative 4 squared, negative 12 squared, will give you 14. So our unit vector UEA would be equal to 6i minus 4j minus 12k over 14, and this gives us 6i over 14 minus 4 over 14 j negative minus 12 over 14 k. So that's our position vector, or that's our unit vector. So by this equation we can now express FEA in Cartesian vector form by multiplying its magnitude by the unit vector. So FEA is equal to FEA, here in this case the magnitude. Let's do that. UEA, which is the unit vector. So I multiply this by 6i over 14 minus 4 over 14 j minus 12 over 14 k, and this will give us 12i minus 8 j minus 24 k. So we've expressed the FEA in Cartesian vector form, and we do the same for all the others following the same approach. We're going to say for FEB, working with this coordinate and the coordinate at A and B. So our position vector would be EB. So EB, we're subtracting the coordinates of E from the coordinates at B. So if you notice directly, you can see that we're subtracting 6 minus 0 for the I direction, which gives us 6i. Then 4 minus 0 will give us plus 4j. then 0 minus 12, you get negative 12k. In the magnitude of this, EB will give you 14 as well. So you notice that your unit vector UEB would simply be 6i over 14 plus 4j over 14 minus 12k over 14, and your force EB will be equal to FEB magnitude multiplied by UEB, so it's simply 28 by 6i over 14 plus 4j over 14 minus 12k over 14, and this gives you 12i plus 8j minus 24k. Similarly, EC for EC we have we're going to have negative 6 minus negative 6 minus 0, we're going to have 6i minus 4j minus 12k, and the magnitude of EC would be equal to 14. Then our FEC would be equal to 28. You find that the position vector will simply be negative 6i, the unit vector rather, of 14 plus 4 over 14j minus 12 over 14k, and this works out as negative 12 plus 8, negative 12i plus 8j minus 24k. And the last force, let me write it here. ED be equal to negative 6i minus 4j minus 12k. So ED will be equal to 14. So you could see that. Okay. So ED, write it here. ED is equal to 14. This is our 14. And our FED would be equal to 28. The unit vector would be 14i over 4 over 14j minus 12 over 14k. There. This works out to be negative 12i minus 8j minus 24k. So our resultant force FR in Cartesian vector form will simply be the summation of fxi, which are the I components of our Cartesian vector forces, our I there and our I there, plus a summation of yj plus a summation of zk. So when you sum everything up, the i's and the j's and the k's separately, you find that you end up with 0i plus 0j minus 96k, which means that your FR can also be written as simply 1 as negative 96k. This will be your resultant force in a Cartesian vector form, whose magnitude would be FR would simply be equal to, if you like, you can say 0 squared I, or 0 squared plus 0 squared plus negative 96 squared, and this will simply give you 96 kilonewtons. That's your answer. So what does this mean? Well, getting back to our initial diagram, we notice that the resultant force will simply be a force acting directly along the z-axis in the negative direction, because we found that our resultant force is actually Fr is equal to negative 96 I in Cartesian vector form, so whose value is also equal to 96. This force is going to be acting directly along the z-axis in that direction, which makes sense because the four forces are equal. The resultant force, which is the summation of these forces, will act directly in the middle, in the center, in the z-axis.